All right, guys, welcome to statistics. We had a little bit of a break there, but we are back with our new packet. Hopefully you guys picked this up on Monday. If you weren't able to pick it up on Monday, here's a couple ways you may already have it or can get it. First off, it is in the Google Classroom. The post directly below this one. There's an electronic version of it. You can get it right there. Or if you have the previous packet, this is actually just an excerpt from that, meaning that this is a couple pages in and it's just a few pages there. I printed off and gave all of you a new one in case you turned in the previous packet and didn't have this anymore. So it's very likely you may already have this in your possession. I also want to answer one question that I got from a couple people before we jump into working on these problems, and that's about the credit that this packet is worth. You guys know that the previous stuff we've been doing can help your grade but can't hurt your grade, right? I heard a couple questions of, is that the same for this packet or future packets? And that is absolutely true. All of these packets can improve your grade, but none of them can make it go down. So if you are unable to complete the work, no problem, as long as you are happy with the grade you currently have in the class. So what we're going to do is we're going to pick up right where we left off last week with confidence intervals. And in this video, we are going to take a look at question 31 and question 32, and then there's going to be a couple for you guys to try out as well. So number 31 reads, some food retailers propose subjecting food to low levels of radiation in order to improve safety, but sale of such irradiated food is opposed by many people. Suppose a grocer wants to find out what his customers think. He has cashiers distribute surveys at checkout and ask customers to fill them out and drop them in a box near the front door. He gets responses from 122 customers, of whom 78 oppose the radiation treatments. What can the grocer conclude about the opinion of his customers? Okay, so here's what we want to do. We want to take a look at some of the numbers here, right? We have this survey. The number of people that it went out to, or the number of trials as being the vocabulary we tend to use, is 122. Of those, 78 were what we considered, what we were looking for. We would be bothered by that, no, we don't want it to happen, that kind of thing. And then, how many did we have that were okay with it? Well, let's figure that out. If we had 122 total, and 78 of them said they didn't like the idea, then that means we had 44 that were okay with it. Now, let's remember what we said last week about the numbers that we have to have when we are trying to make a confidence interval. And one of those important numbers was there are at least 10 in favor and 10 against, or 10 successes, 10 failures, whatever terminology you want to use. So we have to make sure each of these categories had at least 10 people in it, or 10 responses in it. And in this case, we're good. There's 78 in one, 44 in the other. That's plenty. So we're able to go ahead and make a confidence interval here. So what we want to do is we want to find first the proportion of people who did not like the idea. Well, the proportion of people was 78 out of the 122. So let's figure that out. So to get P, the proportion, we can do 78 divided by 122, which would get us 63.9 or 64% of people do not like the idea. So that's going to be our proportion. That's going to be our average, right? But to make our confidence interval, we need to know our margin of error, or our sampling error. And we have an equation to do that. That equation being the square root of P times Q over N. Well, we've already defined a lot of this. We know N is 122, right? We know P is 0.64 because that's our proportion. Now let's remember that Q is the opposite of P in a lot of ways. It is the number that effectively makes it equal to 1, right? Like 1 minus P is Q. So 1 minus 0.64 is going to get us 0.36. So let's solve that. Square root of 0.64 times 0.36 divided by 122 gets us 0.04, and I'm just going to round that to 4%. So we have a sampling error, a sampling deviation, whatever you want to call it, of 4%. Now, if we want to turn this into a real 95% confidence interval, then what we do, if you recall, is we add and subtract that standard deviation, that sampling error, twice to each side of the proportion. So we have 0.64, and on one side we are going to add 0.04 twice, and on the other side we're going to subtract 0.04. Now obviously my math equation I'm writing here does not technically work in the real sense, but I think it illustrates what we're trying to do. So if we subtract 0.4 twice from our proportion of 64%, then we end up with 56%, right? Or 0.56. If we add 0.4 twice to 64, then we get 0.72. So for a 95% confidence interval, this grocer is able to say that between 56 and 72% of his customers do not like this policy, do not like this idea. And the key thing that I really want to mention here with the 95% confidence interval is that you do have to remember to add the number twice. It's very, very easy to just add 0.4, subtract, or 0.04, subtract 0.04, and call it good. But that's a confidence interval of 68%, right? Because that is one standard deviation outside the mean is 68% of the data. We got to go 2 standard deviations outside the mean for the full 95. All right, so let's take a look at one other problem here. 32 is the local news. It says, the mayor of a small city has suggested that the state locate a new prison there, arguing that the construction project and resulting jobs would be good for the local economy. A total of 183 residents show up for a public hearing on the proposal, and a show of hands finds only 31 in favor of the prison project. What can the city council conclude about public support? All right, so let's take a look at it. How many trials do we have for this? And again, trials is kind of a generic fancy term for it, but how many people are in part of this? How many people gave their opinion? And in this case, that's 183. 183 showed up to this meeting, right? How many people were in favor of it? I'm going to say P in an approximated sense, because of course this is going to have to be a decimal, but it is the proportion that we're looking for. And that's only 31, right? 31 people. And that would mean Q, the opposed, is going to be 31 less than the 183, the total people that were there. That's 152. So again, let's think about this. Does it meet our requirements to find a 95% confidence interval? Does it have at least 10 in each one of these? It absolutely does. So we can do it. Let's solve this. So for P, to get our actual number, we're going to take the number of people who said they were in agreement with it divided by the total number who voted. That would be 31 divided by 183. And that's going to be approximately 17%. So 0.17. Q is the opposite of that, 1 minus that, so that is going to be 0.83. So we are going to be able to say our true proportion, not true proportion, but our proportion is 0.17. Now we need to find the standard deviation through the same equation that we used right up here. The square root of P, 0.17, times Q, 0.83, divided by the number of trials, 183. So let's do that. 0.17 times 0.83 divided by 183, and we get 2.7%. I'm going to round it up to 3% just for the simplicity's sake. I mean, whenever you guys are doing problems, I don't mind if you do that rounding the nearest percent either. So we find out that our standard deviation is 3%, 0.03. So to find our confidence interval, we are going to add this number twice. Again, twice to each, we're going to add it twice to our proportion, and we're going to subtract it twice. So twice this number is 0.06, right? So 0.17 minus 0.06 is going to be 0.11. 0.17 plus 0.06 is going to be 0.23. So the mayor is going to be able to conclude with a 95% confidence that between 11 and 23% of residents support this prison coming into their community. That's not a lot. So here's what I want you guys to try out. I want you guys to do number 33 and number 34. Try those out, see how they go. If you have any questions about it, email me. Otherwise, I'll see you guys tomorrow, and we'll keep this going.